In this section, we're going to look at taking models, situations, and contexts and turning them into linear inequalities. It's going to be very similar to what we did in the previous video when we took situations and turned them to linear equations, but now they're inequalities instead of equations. So our strategies are still going to be the same. We want to subsearch, we want to pick out those key details, and then try and piece it together. So for problems 1 and 2, use the following scenario. Joanne and Richard volunteer at a hospital. Joanne volunteers 4 more hours per week than Richard does. In a given week, they do not volunteer for more than a combined total of 16 hours. X represents the number of hours that Richard volunteers. In question 1, we want to write an expression in terms of X, which represents the number of hours that Joanne volunteers. So we know that Joanne is going to volunteer more than Richard. And we know that, let's say Richard volunteers for 5 hours. We know she's going to volunteer for 4 more than that, so that'd be 9. Let's say he volunteered for 10 hours. We know she's going to volunteer for 14 hours because, again, it's 4 more. We don't know what Richard has volunteered, though. We know that we have a variable that represents it, X. So if Richard volunteers for X, Joanne is going to volunteer for 4 more than that, so X plus 4. We want to know which inequality best models a situation. So it is not A. A would represent the number of hours that Joanne volunteered. What it's saying here is that together they don't work for more than a combined total of 16 hours. So what that tells me, and then, is we're going to have an inequality where we have less than or equal to, and probably 16 because that's the most number of hours they can volunteer for. Well, if we take Joanne's hours plus Richard's hours, so let's write this out, Richard plus Joanne, we know that's going to be less than or equal to 16. Richard's hours are X. Joanne's hours are X plus 4. So if we put those together, we would end up with 2X plus 4 less than or equal to 16, which would be choice B. For 3 through 5, we have a landfill. On January 1st, 2000, so it seems important, there's a date there, there was 175,000 tons of trash in the landfill and has a capacity of 325,000 tons. Each year since then, the amount of trash in the landfill increased by 7,500 tons. So again, that was each year. Let Y represent the time in years after January 1st, 2000. So 3 says, write an expression in terms of Y, which represents the number of tons of trash added after January 1st, 2000. So we're looking for a rate of change. They tell us in the question that the amount of trash increases by 7,500 tons every year. So if we have 7,500 tons every year, we can find that total by taking 7,500 and multiplying by the number of years since 2000. So that would be Y in this case. So there's our expression for the amount of trash that we're adding to the landfill. 4 says write an expression in terms of Y, which represents the total trash that has been that's in the landfill after January 1st, 2000. So this is not the same question as number 3. Number 3 is saying, how much did you add to it? But number 4 is saying, well, didn't we already have some in there? And we did. We had 175,000 tons of trash already in the landfill. So there's our expression for the amount of trash in the landfill at any point in time. 5 gets a little bit tricky because we say that it's at or above capacity. Capacity is an ideal number. It's basically saying that if things are perfect, the landfill is working perfectly, then 325,000 tons of trash would be our capacity. It is possible, though, that it would be over capacity. And I like to think of this in terms of, let's say the Blackhawks. They make the Stanley Cup Finals again this year. Now, we know that the Blackhawks can only sell a certain number of seats, and that would be effectively your capacity, your seating capacity of the stadium. But in a lot of cases, they will actually sell standing room only tickets as well. So they're above capacity as far as the seating capacity goes. And it could be the same situation here with the landfill. it may be overflowing, or it may just be that, it's not a number that we really want to be above, but in this case we are. So we want that inequality that shows that we're at or above. So that would be, to me, a greater than or equal to relationship. So we're going to take our expression 175 plus 7500y and find out where's it greater than or equal to 325. And there it is. Choice D. 6 through 8 uses the following scenario. A particular company charges advertisers a one-time cost of $500 in addition to $450 for every 1,000 times an advertisement is shown on the website. An advertiser wants its ad to appear m,000 times on the web page, but does not want to spend more than 5,000. So write an expression which represents the charge for m,000 times an advertisement is shown on the company website. So we want to know that cost for every 1,000 times that website is shown on there. And it's buried in that question. It's 450 times m, which is the 1,000 times that it's been shown. Which of the following best represents does not want to spend more than 5,000? So they can spend 5,000, but they can't spend any more than that. So that would be a less than or equal to relationship. And so that would be A. And then which of the following inequalities best describes the situation? So the difference between 6 and 8 is we also have that initial cost. And that initial cost, that one-time fee of $500, applies to how much they're going to spend. So in this case, it looks like the best choice would be that 500 plus 450m less than or equal to 5,000. Now in this next activity, we're going to actually go ahead and solve some things. So we'll just look at one quick situation here, and I think we'll get the basic idea of it. For problems 1 through 3, use this scenario. Aria is buying refreshments for a birthday party. She intends to get, oops, that's better, intends to get an ice cream cake for $23 and some cupcakes for $2 each. C represents the number of cupcakes that she can purchase. Write an expression in terms of C, which represents the total amount of money she spends. So it's not just cupcake, it's the cupcakes and the ice cream cake. We're buying one ice cream cake. We know that's $23. The cupcakes, we don't know how many we're going to buy, but we're going to use that variable C to represent it. So it would be 23 plus 2C. In question 2, she's got a budget of 45, but she does not have to spend the entire amount. So $45 budget, does not have to spend the entire amount. So we can say she spent 43, 41, who knows? But we're going to say less than or equal to. She can't spend more than 45, but she can definitely spend less. Use your answer from number 1. Write an inequality which represents this. So we have 23 plus 2C is less than or equal to our budget, which is 45. Now it looks like what we're going to do in number 3 is find the number of cupcakes that she can purchase. So we're going to solve for C. And to solve for C, it looks like I've got two things I need to do. I'm going to take that inequality and I'm going to subtract 23. I'll continue my work down here. So we'll have 2C is less than or equal to 22. And then I'm going to divide by 2. C is less than or equal to 11. So what that says is that she can buy 11 cupcakes, 10 cupcakes, 9, whatever, but she can't buy any more than 11. So D would be the best inequality that represents that situation. So again, the difference in that part is that we're going to go ahead and take that inequality that we set up, and we're just going to solve for the indicated variable.